In this video, we are going to look a little bit more in detail at how you can run programs in your Docker containers, and also how to do more advanced things with your Docker files. So as usual, I'm going to use the Python plus MySQL application that I've been using throughout the term. And we're going to look at how we can set it up using Docker. So we've seen in the other video how to set up Nginx and a MySQL database. I'm not going to go too much into this. I'm going to focus on the setup of the container, which is going to run the middleware, aka the backend, the Python application connecting to the database, and that will be queried by Nginx as a reverse proxy. So in the final situation, for the lab is going to be 3 Docker containers, 1 running Nginx, 1 running MySQL, and 1 running the Python application. So this is the container that we're going to look at. And we are going to build a container that runs our Python application. But first of all, we're going to look at how you can run programs in your Dockerfile. Our application is running Python. So we're going to use the Python Docker image that's available on the Docker Hub. Version 3 is fine because we're going to use Python 3. And I created a folder for this lab, which I called part 2. And inside this folder, I'm going to create different folders for all my Docker containers and their build files so that it's easy to stay organized. So the first thing that I'm going to do here is create a folder for my application, my Python application. I can see it here. And inside that folder, I'm going to create a Docker file. And this Docker file is going to use Python version 3. So we are going to use from Python 3. Once we've done that, it's pretty easy. What I'm going to do is get back to the main folder, which is where I have my app directory. And I'm going to build this Docker container in the app folder. So I'm going to build it and give it the name app. And I'm going to build it from the app folder. So because I don't have the Python image on my computer, it's going to download it from the Docker Hub. There are a couple of layers to download, and it's a pretty big image because there are lots of binaries coming with it. Most importantly, we have Git, and we have all kinds of programs that are going to be very useful for us. So we're going to see that in a minute. Okay, so we have built our container. And the thing is that at the moment, this container doesn't do anything at all because the Docker file just contains the from instruction, saying that it's essentially the same image as the Python 3 image from the Docker Hub. What we could do, though, is run this container, this app container. We tagged it with app, so we can use -t app. And we can, for instance, run a bash process. So when you use Docker run, if you don't use any arguments after it, then it's going to run the default program that's supposed to run in the image. We're going to look at that very soon. But you can also, in most Docker containers, you can also give it a program name, and that is going to run the program. So here I run the bash program inside my Python container. So here I can run Python -v, and I can see that it's running Python 3.10. I probably have Git. Yeah, I have Git available as well, so I can Git clone directories, and I can download things from the internet using wget. So this container has a lot of installed binaries that I can use, and it has bash as well. So I can basically run a bash process by appending bash at the end of my docker run command. A detail here is that I'm using -i. This is an option to make sure that the Docker session is going to be interactive, which is something that you need to run a shell process. If you don't have any interactivity required in your command, you don't need to use the I. But in our case here, we're going to send and receive IO to and from the Docker container. So we need to use -i to make sure that it runs in an interactive way. So that's the first thing that you can do with Docker run. What you can also do, and this is more interesting, is to run commands directly from inside your Docker container by changing parameters in your Dockerfile. So the parameter for the command that is going to run by default in your Docker container is CMD. And the CMD instruction has two forms, the shell form and the exec form. The most recommended way of using the CMD command is to provide a list of instructions that you want to run. So for instance, if I wanted to check the Python version installed in that container when I run the container, I can use Python -v. So here that's going to transform into two parameters, Python and -v, because that's the command that I would like to run in a list format. So basically each word is going to go into a separate element of the list. So now I changed my Dockerfile. So I need to build my Docker container again in order to update my image. So now if I save that file and I build my app container again, that's pretty quick. And now I can run it. And the default command that is going to be run is Python -v, which is the command that we have specified in our Dockerfile. The good thing about this command option is that you can still override it in the command line by adding the argument as a last argument to your Docker run command. So here, if I run this, now it's going to override the command that is defined in my Dockerfile, and it's going to run bash instead. So this is why I have now an interactive shell session running bash. Now, there is another way of running commands and programs in your Dockerfile, which is the entry point instruction. It's very similar to the command that you will use in your Dockerfile. It's just that it's a different way of overriding it. So basically, the command, when it's defined in your Dockerfile, can be overridden at the runtime of your container, and you can also change it in your Docker Compose. The entry point is more like the default command that you want to run in your container, but that you don't really override usually. And then when you use the entry point in your Dockerfile, the command instruction is going to be appended to the entry point that you have defined in your entry point instruction. So this is a little bit confusing. So here, as an example, if I would like to change that into something different using entry point, I would add entry point. Because this container is a Python container, we kind of expect it to run Python as the default command. So we can use that in the entry point. And then we can change the command to now hold the arguments that are going to be added at the end of our entry point command. So now my entry point is Python and my command is -v. So if I save this, build my container again. Now if I run the container, I still have Python 3.10, which is the output of Python -v. entry point Python command -v. Because now we're using entry point and command, we can run different commands by changing the parameters on the command line. So these parameters on the command line are going to be appended to whatever entry point you have defined in your Dockerfile. So for instance, you can run -v, and then that would run Python -v, or you can run -mpip -v to get the pip version. So in that case, my default CMD arguments have been overridden, but my entry point remained. So here, this is Python -mpip -v, which is actually executed in the container. So this is important to understand. There are two steps in the life cycle of a Docker container. You have the build stage, where basically all the instructions that you have in your Dockerfile are going to be run, and then you will get an image as the output. And then there is the runtime, which is when you Docker run the container or you Docker compose up your infrastructure. And then your Docker containers are going to run the commands defined in the CMD/entry point instructions of their respective Docker files. Now, let's move ahead and use this knowledge to set up the Python container that is going to run our web application connecting to our MySQL server. So what I'm going to do is keep this Dockerfile here, and I'm going to adjust the entry point and the commands later. But now I'm going to think about what needs to happen in that container. So basically, when you run this container, you are the root user. You can actually check that. If you docker run -t python 3, who am I? You will be the root user by default. So you have a lot of things that you can do as the root user. One of the things that we're going to do, obviously, is to create a new system user to make sure that our processes are not going to run with root privileges. So it's always a good idea to not use privileges that are not required. So we are going to run a command in our Dockerfile, and we are going to add this user to the system. So I think user add should do the trick, and we are going to make sure that we create the home folder. We're going to use /app as the directory, and this user is going to be called backend. So at that stage, after that run command has been run, you will have a backend user in your Docker container with the home folder /app. And pretty much everything else that you are going to perform in the build stage of your Docker container is going to use this user, the backend user. So in a shell script, you would use sudo or su. Here, we are going to use user to change the user who is actually running the container. And we're going to use backend because that's the user running the container. Here, I'm going to remove the entry point. I'm just going to change the command to Python so I can actually override it whenever I need for debugging purposes. So here I have my user created, and then I changed into my backend user. That's good. I can save that, and I can build my container again. So now you have more steps. So you can see that each instruction in your Dockerfile is creating a Docker layer. And well, let's run it. Now I can run who am I in my app image. And now I'm the backend user because I used user in my Dockerfile. So anything that happens after that user instruction is going to be executed as this user. So that's good. Here we have /app as the home directory for that user. And most of what we are going to do is going to happen in that folder. So we can use another instruction, which is WORKDIR, which is working directory. And we can make sure that we are in the /app folder. So once again, everything that happens below the WORKDIR instruction is going to be in the context of that folder, so inside that folder. You can have multiple user instructions if you need to change into multiple users, and you can have different WORKDIR instructions as well in case you need to work in different folders. So build that again. And now if I run it, now my working directory, my current directory is the /app folder, which I have created when creating my backend user. So the next step now is going to download the source code. So I have a link here in my clipboard, and I'm going to run wget. This is the URL of my application from GitHub, and I'm going to download that into, let's say, /tmp. I'm going to use -o for output, /tmp /source. That's it. So now in my Docker container, I will have the source code available in /tmp /source.zip. So the next step would be to unzip that source code /tmp /source.zip. So here I'm not exactly confident about what this is going to do because I'm not sure that the container has unzip and where it's going to unzip the files. So I'm just going to build it and see what happens. Okay, we can probably change the options for wget so that we don't get so much output here. I guess using -qq should do it. Maybe -s for silent. I'm not exactly sure. No, -s doesn't exist for wget, it's for curl. Okay, all right. Okay, so it looks like we do have stuff, but in which folder was this created? I am not sure. So I'm going to inspect my container by running a bash process inside it. So this is something that you do for debugging purposes. When you work on a production container, you are not going to use all these binaries, bash, etc., etc. Actually, it looks like it unpacked the source code into my home folder, which is useful. So now it means I have this here, and inside this, I have my backend. So that's the source code that I want to set up in my container. So in my Dockerfile, I'm going to get back to it. So now I do have to copy. So I'm going to copy, recursive copy using -r. I'm going to copy from, I think that's the name of the folder. I'm going to copy this into /app /src. So now all my source code should be in /app /src. And just for to make things a little bit cleaner, I'm going to remove that folder now that I copied the files that I needed from. Okay. Build it. Okay, and run it. So now I have my source code here, and inside my src folder, well, I have all the things that I wanted. That's good. And including the requirements.txt, which contains all the dependencies for my application. So I can get back to my Dockerfile, and now I can run Python -m pip install -r. That's going to be in /app/src/requirements.txt. And that's going to install all the requirements for my application to run. To build this. Okay. It should use --user. I think that would be a little bit cleaner. Yeah. Okay. So that's interesting as well. It tells us where the binaries that were installed by our pip command were installed to. So in the .local/bin folder, which is not in our path. So we need to keep that in mind. But the container did build, sorry. So now I can run it. Okay, and I have a bunch, I have a bunch of things installed. So here in the container, I cannot just run gunicorn like that because it's not in my path. So I need to run /app/local/bin/gunicorn. And then I can use the full path to run gunicorn. So let's do that. Edit the Dockerfile. And we have installed the dependencies. So now our next step is going to run gunicorn. So for gunicorn to work, we need to give it the app module in Python. So that's going to be our next argument. This app module, how is it working again? So in SRC, oh yeah, I need to run WSGI:app because that's where my app is defined. Yep. So let's make this happen. So in the Dockerfile and in Docker container, because your container is the service, you don't have to define a unit file or anything like that. Basically, you are going to set up the container so that it runs exactly as you expect it to run. So here, we're going to run the application as if we were running it from a terminal. Gunicorn, and actually this is in /app/src. So I can change my folder here by using another WORKDIR instruction and WSG app. And then you are going to bind this to, let's say, port 8000. So that means that your Docker container, when you build and you run it, if I've done everything right, will listen. Well, your gunicorn process will listen on the container on port 8000. Okay. Now, if we run the container, we see the output of our gunicorn process. And here we have a problem. We have an exception because we cannot connect to my SQL server on 127.0.0.1. And that's obviously because we cannot connect to localhost. Our Docker container is running just the Python backend. So it cannot connect to another database container at the moment. So we need to create that container in order for that to work. So this is where Docker Compose is going to come in handy, because it's going to allow us to make all these containers talk to each other using a dedicated network. So we are going to make that happen now by using a Docker Compose file. So once again, use version 3. And then here we'll have, let's say, our app service. So we're going to build not in dot anymore because we have a specific folder for our app container. So we're going to use build app. So I should be able now to docker compose up -d. It built my container. And obviously my container doesn't work because, as expected, same problem as before. My gunicorn cannot connect to the MySQL database because it doesn't exist and it's not configured for that. So because we are going to use Docker Compose, that's going to make our life easy, because now what we can just do is add a database container. And this is going to use MariaDB. And we're going to provide a couple of env variable, MySQL random root password 1. And then MySQL user, let's make it backend. MySQL, is it database? I'm not sure. Let's make it video, and MySQL password super secret. Let me just double check these parameters here on the Docker Hub. Just a sec. Yeah, so we have MySQL database here. MySQL random root password, and MySQL user and MySQL password. We can inject that in our container, random root password, backend video, super secret. So obviously we are going to use these in the backend.conf. So we need to make sure that our backend.conf contains the values that match these ones. So there are a couple of options we can use here. One of them will be to basically get the configuration file from the source code. So here in the Git repository, like that. Just check my screen. So here on the Git repository, you have the source code, so you can just copy it and create in your app folder. You can use backend.conf, and here you are going to use the right values. So your database container is called DB service in your Docker Compose. So we can use DB here. And I forgot I used. So MySQL user is backend. The database is video. And MySQL password is super secret. Okay, so make sure now we have to make sure that this depends on DB container. Let's go ahead and make that happen. Okay, what's going on here? All right, exit 3. It looks like this didn't work. Cannot connect. Oh well, yeah, my bad. I created that backend.conf file here, and I did not put it in the Docker container. So that's pretty useless for now. So I'm going to change my Docker file, and I'm going to make sure that I'm copy. Well, I'm going to copy backend.conf into /app/src. So copy in a Docker file copies a file from your Docker host to the Docker container. So this is on my host, and it's going to copy it into /app/src. Because the working directory is already /app/src, I could have used dot or something like that, but it's just clearer, in my opinion, if I make it that way. All right, so we can rebuild using Docker Compose, using the --build flag. You can see that my backend configuration file was copied over. And now my container is actually up. Let's have a look at the logs. It looks like it's actually working. So now we have a couple of issues. This container is listening on port 8000, but you can see here that it does not show up as a port on the Docker Compose output. This is because we did not declare the port in our Dockerfile. So we are going to improve that, edit the Dockerfile, and we are going to express the fact that our container is listening on port 8000 by using the expose keyword. Okay. Now you see that 8000 port being exposed in the Docker Compose output. Now I'm going to check what is actually going on with that container by exposing that port to my actual Docker host. So here I changed the Docker Compose, not the Dockerfile, so I don't need to rebuild. I can just Docker Compose up -d. And here I rebuild my containers, and my 8000 is now exposed on my Docker host. I can try to access it. And if you try to access it in your browser, you may see something like that. So I'm not sure if that's what we are expected to see. All right, yeah. So here, this is the index page. Very conveniently, it has an error message that says that you should not serve the HTML pages through Flask, because this is what your Nginx container does. But the actual API is listening on /JSON. So here you can see that I have nothing on /JSON because my database is most likely empty. We can actually inspect that. I'm going to exec db MySQL. Probably not going to work because I need to be, I forgot again, I need to be the backend user. So my super secret. Okay, so that's my database server here. I have my video database, which was created here by my end variable. So I'm going to use that, and then okay. So my table was created because when my service started, it creates tables if they don't exist. Actually, there is nothing here, which is kind of expected. And we can try to insert some stuff here. So insert into item. How do we do that? Values, I think. And I think I'm not sharing the right screen. Yeah. Okay, so I was not sharing the proper screen. So what I did is that I exposed my port using the expose keyword, and my port is exposed here, and then I forwarded my port 8000 to my Docker container by using port 8000, and then I run everything, and then I connect it to my database, and I realized that my database was created here. I have my table here, which was created when I started my service, and now I'm trying to insert data in my database. I'm not really sure of my syntax with my SQL. I'm going to try that. Well, that actually worked. Now, if I move back to my browser, you have the API output of the backend service with a student. Let's try to add another one. Okay. Here, now we have our 2 students here. All right. So now, if you have a look at your Dockerfile once again, this is the complete actual Dockerfile to run the application. What's important to remember is the WORKDIR user that allows you to change users when building your container. Each of these commands, of these run commands, is actually going to create a container layer. So if you want to be efficient in building your containers, it's actually a good practice to sort of combine them together in order to make fewer layers when you're building your containers. So you can do that by chaining your commands using the double ampersand sign. And I'm going to connect all these lines so that I end up with just one command here. So I try to keep them organized in a logical way. So this is downloading the source code and extracting the backend source code into /app/src. This is installing the requirements. So in my opinion, that deserves a separate step. And then we have the override of the backend.conf. That's something we cannot avoid. We have to have a separate step for that. And then we have our command here, which can be overridden if we wanted to. So now this is the final version of our Docker Compose environment for the backend. My bad. I need to build it again. So now you'll see that all these commands are going to be run in one layer, making our build slightly more efficient. We could also use the no warrant script location with pip just to make things a little bit nicer, but that's not really required. Okay, everything's working. In the final version of your infrastructure, you don't want to access the application service from your Docker host, because you will just access the Nginx reverse proxy. So you will access the Nginx reverse proxy. Nginx will connect to the backend application. The backend application connects to the database container. So we can remove that port, and then everything was already built, so that was not useful. And now our thing is running here on port 8000, and it's waiting for connections on port 8000. And what you need to do then is to create an Nginx container that has the static front-end files, and use app as the target for the API redirects in your Nginx configuration file, which is what you're going to have to do in the lab next week.